Welcome back to the workshop, and I hope you enjoy this little catch up. I've entitled it an update, and I suppose in some respects it is, but God, I've been waiting for 10-15 days now for some bits to come from China, and at long last they're starting to dribble in, so it's going to be a bit disjointed, but you'll see I've been getting on with little bits and bobs here and there. Okay, I'll take you over to the lathe first and show you what's been happening there. Brief update then on how I'm getting on with the ELS installation. As you can see, I've taken off all the change gears, leaving just a 45 tooth gear on the spindle. I don't think you can see it, but I've 3D printed off a matching one that will go somewhere under here, attached to the encoder, which has arrived. The hole in this pulley is not big enough, but the encoder will be mounted on a plastic 3D printed mounting against this casting with the gear on here that engages in there, so the drive 1-to-1 to the encoder. I've also printed off a temporary bracket in carbon reinforced PLA. It's not very stable at the moment, and hopefully you'll be able to see the stepper motor here. That will be mounted in front of the lathe. I've printed, or rather I've drawn up another spindle mount which is gives more rigidity, but I'm not going to print it out just yet because I'm waiting for the belt to arrive. I originally ordered the wrong shape tooth belt for the pulley profile, and that arrived, and of course when I got it I found out what I'd done, so I've had to send off for another one, and well, hopefully that will arrive tomorrow. That's Monday, and I'll check the centre distance is correct before I print off another one of these. So that's the arrangement for the electronics lead screw. The ELS display and gubbins has arrived, as you can see. I haven't got the power to it yet, but if you've watched the demonstration video you'll understand what all these buttons do, and it'll all become clear when it's fitted. That will mount up on top of the headstock somewhere, I suspect. I may have to make a custom cover and mounting for it, because I don't like the way these connections come out the top of it with just wires flailing around, so I'll redesign that, I think, and see what I can do about printing off a new one, make it a bit more streamlined, up to about there I guess, and hopefully it'll look a little prettier, or at least not so basic, shall we say. At the moment the lathe is set up, so I'm just about to bore out the large pulley to go on here. I've disposed of my brooches, all apart from one, and the one I have got is the wrong size to make the keyway for here. It's a 4mm keyway, but there we go. So I'll take you round to the other side and show you what I've done. Here we are at the business end of the headstock. I've mounted the large pulley in the chuck, checked the face for squareness, and I've drilled a 4mm hole at the radius of the keyway, so that when I file a keyway groove, as I'm going to have to do, the keyway will come across the diameter of that hole. I'm about to drill it through with an 11.8mm drill. That's the nearest to 12 that I've got, the shaft on the motor being 12mm diameter, and then I shall ream it to 12mm. I don't have a boring tool, otherwise I would preferably use that. So, oops, wrong way. I'll start drilling. If it starts to snag, then I'll stop, and I will borrow or purchase a boring bar. But again, I'm still waiting for the multi-fix tool post to arrive from China, held up by the Chinese New Year, and until that arrives, I'm loath to use this horrible 4-way job. But there we are. Whoops, kicks the stand. So, sorry about the wobbly wibblies. Switch on. Forward. Hopefully that will be fast enough. Like that, does it? Perhaps I'll spray some WD-40 on, and I'll move the camera back so it doesn't get splashed. So I'm afraid you're not going to see this. So if it all goes wrong, you'll have missed that. Well, as it happened, that worked out okay. You missed it, unfortunately, but there again, as I've said many times before, we've seen someone drilling a hole and reaming it before now, and that pulley fits nice and snugly on there. The key is actually stuck in the pulley, but slides on and locates the pulley just nicely. Get a bolt on there. I'm going to make up a little collar so that fits snugly on there, but that's for another day. And it's just a simple piece of turning, which again you won't want to see. I don't particularly want to do it, but it's got to be done. I don't know what the next job is. I'll wait for the timing belt, I suppose, and then I'll come back and see what else is to be done. But that's it for now. On to the next shot. I'm going to interrupt myself here just briefly to explain that those last few shots were taken about a week ago. Time has gone on, and a few more bits have arrived, and the rest of the video is well, been shot today, so it's as up to date as I can get it. Enjoy. And the first and most significant arrival, of course, is the multi-fix style tool post. Diddy, isn't it? It came with just 4 tool holders, which I mounted a couple of 10mm square tools in. Fortunately it all fitted. I have to make up a new mounting bolt for it because this is a little loose fit, but for the moment it works okay. I'll make sure that that's lined up. And it's quite rigid, unlike the lathe which wobbles about, or at least the bench wobbles about, and it sits nicely on the centre line with 10mm tools. So I'm very pleased with that. For the price it was remarkably good. I think it was about £150 all in, the tool post and as I say 4 tool holders. That's UK pounds of course. What's that? Current rate of exchange, significant number of dollars, something around 100 and no, more like $200 I would think. There we go. And I'm very pleased with it. Works out very well. I'm just still waiting for a boring bar to come again from China, but I understand that the delivery company tried to deliver it yesterday, but for some reason didn't. But there we go. I'll move up to the headstock end of the lathe and show you what I've been doing on the electronic lead screw front. Here we are at the business end of the lathe. As you can see, and I think I previously showed, I've removed all the change gears and feed screw gears, and I've 3D printed out this bracket to mount the stepper motor. It's only a temporary one at the moment because the timing belt hasn't arrived, or at least the correct one hasn't arrived, but when it does I'll be altering the distance between the centres so that there is no significant slack in the belt. It's got to come out about another 10mm according to my calculations, and the one that I print out will also have a stabilising mount which will screw into this box and hopefully be able to support the weight of this. If it doesn't, I'm going to have to get a steel bracket, either laser or plasma cut, but we'll find out what happens when the belt arrives and I've printed out a new one of these. It's got a temporary support on there as well, which may or may not stay or be modified. Well, that's progressing. As you can see, I've mounted the encoder again on a 3D printed panel, secured to the headstock using existing threaded holes which were used for mounting the change wheel gears. That moves quite nicely and smoothly, and I'll bring the camera around a bit and we'll have a little play with the electronic lead screw display. I don't know how well this is going to work, but this is the electronic lead screw display. The lathe isn't on at the moment, but if I spin the chuck by hand you can see that the RPM are showing. And there is just one thing I could do to show display is, now I'm pretty new to this, so if I go down to angular mode, This will now show, or should display, the angular rotation of the chuck. I turn it, was to try and do one whole turn, roughly speaking. I haven't got a marker or anything, but there we are. We're back to 360 where we started, which proves that the encoder is working, and also that I've got the right gear teeth on the encoder drive to match that of the spindle. So that's working. Reset that to 0, exit that one. I'll go through the whole of this at a later stage when it's all wired in and what have you, but for now you can change it from millimeters. This is the drive for the lead screw in inches. You can set it threads per inch, and you can even do BA threads, obviously metric and imperial. You can do it for turning, i.e. that's the feed rate. Obviously threading, you can select what thread you want. Down, the length of the thread is for the semi-automatic threading situation. Thread tempo, I'm not entirely sure what that is, so I'll have to check that. Angular mode, which is what we've just been doing, and then there's a test mode, so that when it's all set up you can actually test the movement of the saddle, and you go in and change the parameters. As you can see, I've set them all up. Actually, the teeth for the motor, which is the stepper motor for the lead screw, has got a 20-tooth gear. There is actually a 40-tooth gear on the lead screw, but the pitch of the lead screw only are selectable down to 3 millimeters, and mine is actually 1.5, being a micro mini lathe, so I've had to double the lead screw number of teeth in order to get hopefully the saddle to move at the correct speed. And as you can see, I've set it to the minimum of 3, and like I say, I'll go through all the menus and what have you at a later date, unless you want to watch it on the link, which does it far better than I can, because he wrote the software. It is in French, but I'm not sure. I think he does an actual English version, but there is also subtitles, so if your French is not very good, then you can select the subtitles. You can see a little flashing direction here, which is part of the semi-automatic threading program. Can't say that I'm 100% happy with the plugs coming out the top. I may well design and print a larger box for this to go in, but that is for a later date. At the moment I'm just interested in getting the thing going. Right, I'll take you over to the bench now, and we'll see what I've been doing over there with regards to the rest of the electronics. Meanwhile, back at the bench, in a very untidy state, I regret to say, but I've purchased a plastic enclosure to hold the electronics gubbins, and I'm going to mount them on this subplate which I've 3D printed. The driver will be mounted on this section. Oops, sorry, not the tripod. Difficult to see the screen. Next to that will be a power supply which will sit in that little pocket, and that purely drives the exhaust fan to keep the thing cool. Not that I think it will get very hot, and consequently I've got a tiny little fan which I'm going to mount on one of these holes here, and I have another one opposite which will that'll be open to the elements to get a bit of through flow. Like I say, I don't think it'll get very hot at all, but you never know. The power supply, try and get this in the shot without dragging everything off the workbench. The power supply, I've printed lugs on the frame here, and that will sit in there, and the whole thing is going to be secured inside the enclosure with some, again, 3D printed clamps. I've got 8 of these altogether. That will be stuck to the inside base. The edge of the base plate will go up against that, and then there's a little clamp which goes on there and clamps down on the actual subplate itself. It sounds very complicated and is probably somewhat over-engineered, but that's how I like to do things. The enclosure itself is going to be mounted either directly or via these little cotton reel rubber mounts onto the side of the new workbench, for which I've got some riv nuts. Never used them before, so that'll be another exciting adventure as well. And let me think, that's about it. You're just about up to date now. Postman's been and brought some more PLA CF carbon fibre material for when I print the new bracket out, and also brought my fan, but still no belt, so I've got to wait a little bit longer for that. Frustrating, very frustrating, but a silly little thing like that holds you up. This is the second belt I've ordered. Another one was I didn't read the small print, which indicates that it's hand knitted by Nepalese virgins from the purest Yeti silk or something. It's so rare it takes 6 to 8 weeks lead time, specially made to order, so I'm not holding my breath for that one. And I've ordered another one from a UK supplier, and that should be here yesterday. But there we are, that's the raw mail for you. Moan over, and so is the video for now. So if you have been, thanks for watching. I'll catch you next time. Bye.